Hello everybody, Proto-Benji here. Today we're going to be talking about atoms, the smallest unit or the smallest building block of life and matter, of life and everything you see. But it's not the smallest building block of matter. We'll get into that. Basically, an atom is the smallest thing that holds properties, that has properties that can change. An electron is always negative. A proton is always positive, and a neutron is always neutral. From the name neutron. But the proton, you can think of proton, you can see proton. If you put proton is alliterating with positive. Or plus. That's a good way of remembering the proton. Then the neutron is its prefix is the word, it comes from the word neutral. Because neutrons are neutral, they have no charge. They're not negative or positive. And the electron, the third one, you kind of just have to remember that one. I don't have a good way of remembering it, I just do. But that is that is the charges of the different parts of an atom. But that's not exactly what we're going to be talking about. We're going to be talking about how an atom works. An atom starts with a proton. You have a single proton. And that one proton is hydrogen. And then out in the distance, there's a little electron. This electron is, let's pretend this is a little fluid that is full of protons and electrons. So there's proton and proton and a proton. That is not a P. But these protons will be moving around in this two-dimensional space. And after a while, an electron will find a proton. And whenever it does that, the opposite charges attract. Electrons are negative. Protons are positive. Opposite poles attract, just like with a magnet. North and south poles attract to each other. Negative and positive attract to each other to become neutral, to become a zero charge. And this proton will then have that electron in its orbiting around it. And this little line is called an orbital. An orbital is a way of imagining how electrons move around an atom. And a very good way of imagining how they work, and it's really good in chemistry. That is a hydrogen. If you want to make a bigger element, let's say helium, that has 2 protons. Let's use a subscript of 2. It has 2 protons and 1 neutron. Neutrons really like to go into the middle of an atom because of gravity. Neutrons want to stick to protons, which separates the protons out in a way that makes them more stable, usually. But now that we have the nucleus of an atom. This is not an orbital, this is just to show that it's a nucleus. Helium also only has one orbital. But because it has two protons, it likes to have two electrons, which I'll represent with these dots. Those two electrons cancel out the charge of the proton. So this is now a neutral and a happy, quote-unquote, atom. It is also considered a noble gas because it is not possible to put another electron into here without it being instantly shot out. You cannot bond hydrogen to... No, this is helium. You cannot bond helium to something else without first taking out an electron, which is very difficult. That's why it's called a noble gas. It's noble. It stands alone. It really doesn't like being with anyone else. It really doesn't like being with any other atom. But then we go to hydrogen, the third lightest, which has, I believe... No, this is a hydrogen. Yeah. So, what's after a hydrogen? 1 second, let me search. Let me get a periodic table out. Alright, there's a periodic table. Images. That one works. Alright, there's hydrogen, then there's helium, then there's lithium. Lithium is one of my favorites. Lithium has three protons. And now we're going to stop using that because that gets annoying after some time. And we're going to go to the original Bohr's model. It has three protons, which is this right here. And then it generally wants to have... It doesn't say how many neutrons. 1 second. It generally wants to have 7 neutrons. I mean, it has a mass of 7. So, this lithium, so let's do that. It has 3 protons, and its mass, atomic mass, is 7. To find the amount of neutrons, because electrons almost are weightless, I think they're 0.0 with 8 zeros, 5, which is insanely light. It's mathematically nothing. A proton is 1.0004, I think, and the neutron is only an extra 0.002, I think, than a proton. So they're essentially the same weight, or same mass. But if you subtract the amount of protons from the amount of neutrons, that equals 4. So this atom, this lithium, is most stable when it has 4 neutrons. And this is going to be really cool. Since you can only have 2 electrons on this layer, you put those there. But now it needs another electron, so where would it go? I mean, it could either go into the middle of it, or it can go right here. Yeah, think about that for a second. Exactly. You put it on the next layer. You make a new layer where you put that electron. But this new layer can have 8 different electrons, which is a whole lot more than 2, which makes it a whole lot more versatile. Lithium is fairly common and is insanely reactive. It's a very reactive metal that is used in most batteries nowadays. And that is how you make lithium. If you realize there is 1 electron, 2, and there's 3. Then, let me erase everything. The next one up would be beryllium. Beryllium has 4 electrons. And generally wants to have a mass of 9. So, the amount of neutrons it has, 9 minus 4 equals 5. So it has 4 protons, 5 neutrons. Let's do that for neutral, do that for positive, which is the proton. And because it has 4 protons, there's this layer, which is full, and then there's this layer, which now has 2 electrons instead of 1. Because it has 4 protons, it wants 4 electrons whenever it's stable. That's its most stable state. It has a charge of 0. Well, this is its state whenever it has a charge of 0. In the periodic table, every single atom on it will have a charge of 0. And this is what beryllium would look like. And beryllium is really, beryllium and barium are very cool, but I'll get to that in a later video. Well, all of those in that column are cool. And chlorine and oxygen. I'll get to it later. But that's beryllium. And let's skip all the way up to neon. Neon has 10 electrons. 10. Or it has 10 neutrons. Protons. Gosh darn it. And its mass is generally 26. 26 minus 10 equals 16. So it generally has a mass of 16. Or it generally has 16 neutrons. 16 neutrons. But because it has this full, 1, 2, you go to the next layer, and how many would you put on it? 8. You have 1, 2, 3, 4. Gotta reach down for this one. 5, 6, 7, 8 electrons. But there's a problem. 8 electrons, that means this is full. It's following the octet rule. The octet rule is that every atom wants to have a full outer layer. Then it is stable. But neon and the other noble gases, like helium, do not need another atom to fill that up, to become stable. Because they already have a full outer valence layer. Which this outer layer no matter how many layers there is, the outermost layer is the valence layer, and usually the most important with chemistry. But this valence layer is full, so it, in most cases, cannot react with another atom. Yeah. But that is how atoms are made, how they work, or well, why they work, why they exist. And I'm not going to teach how atoms are created until later on, because that's still stuff that I need to research on my own, and also stuff that is it's a lot more complicated. Like that goes into quantum physics and the creation of the universe, which it's I'm not going to get into that right now. It's an iffy topic. But thank you all for watching. That is atoms. Goodbye. Wait. I'm stupid. Forgot to say one thing. I love you all. Thank you for your support. And please like, comment, and subscribe. Comment your favorite food or something you would like to learn. Any science topic. I will teach you how anything works. I can teach you how a doorknob works. Comment what you would like for me to do, or for me to research and then subsequently teach, and I will try to get it, and I will pick a few of them, or a few topics, to do in the next video. And I might do multiple topics in one video. I might do speed topics. I'm probably even going to make a YouTube short about atoms, how they work, just really fast, but I'll stop blabbling. I'll stop babbling. Thank you all for watching. I love you all you gentlemen, gentlewomen, and other people alike. All of you are great. Thank you for your support. Goodbye.